Okay, so chapter 15, or homework 15, it kind of encompasses a lot of the other stuff we haven't reviewed already, but we're now going to add in these things called asymptotes, okay? Asymptotes are invisible lines that the graph doesn't cross, okay? There are vertical asymptotes, and then there can be horizontal, okay? If they don't have a horizontal, they have a slant usually. I mean, there's some that don't have, there are no asymptotes. But you don't have to worry about the slant, which is really nice because it's an extra step. If you were taking 1710, we do teach the slant asymptotes. Okay, so we are going to talk about rational functions where you have a polynomial over a polynomial. We've already talked about these type things. They are ones that look like these type problems, okay? And when you have these type problems, we now have to worry about our denominator, right? You can't have 0 in your denominator. Okay, we're going to first talk, I'm going to come back, well, let's first talk about vertical asymptotes, okay? They are going to be in the form of x equals some number, all right? And it always comes from the denominator, which we'll find on the next page, not here. We're just going to look at these graphs, okay? These horizontal asymptotes are always going to be in the form of y equals some number. And when I say some number, that means a constant, okay? And because these are invisible lines, you have to write them as equations of lines. So you can't just put 2. You have to have x equals 2. You couldn't just put 1, it'd be x equals 1. Now, I'm going to come back to all of this in just a minute, because to me, this is really wordy, and I've condensed it into this, okay, which I'll get to. All right, so let's first, and I'll come back to both of this in my discussion, especially on the second page. First of all, let's look at this graph here. Let's find our y-intercept. I'll blow it up so that those of you that don't have the notes can see it, okay? The x-intercept is where it crosses the x-axis. It's right here. That is at the point -1, 0. Now in ALEKS, I don't know if it wants an ordered pair or if it just wants -1. I'm not really sure. But just know that's the coordinate for the ordered pair. The y, it crosses the y-intercept is where it crosses the y-axis, which it appears to be at 1/2. Okay, so what we're going to do is it is at the point 0, 1/2. But again, in ALEKS, I'm not sure which way it asks. Even in Pearson, you know, I always say ALEKS in here, but even in Pearson, sometimes it wants this, sometimes it wants that. So I'm not sure. And same thing with ALEKS. It seems like sometimes it'll want the ordered pair, sometimes not. I always say, look at the instructions. You know, the directions might tell you. Bless you. Okay. VA stands for our vertical asymptote. Okay. Now the vertical asymptote is where these two lines or curves don't cross. There is an invisible line, by the way, these all have arrows. Okay, anytime you see these on any of the notes or tests, they have arrows. Okay, if we want endpoints, you'll actually see a round black circle there. Okay, so for the vertical asymptote, you've got this invisible line that goes right through here. Those approach it, but they never cross it. Now, I know this one looks like it's touching it, but that's just because it's really hard to do this without that happening, okay? All right, so that is that invisible line. It's a vertical line at x equals -2. Okay, x equals -2. It has to be this whole thing. If you put -2, it is wrong. -2 does not represent a line. And x equals -2 is now a vertical line. That's the equation of a line. Well, the horizontal one has one right here, where there's one in this graph that's got this invisible horizontal line. But again, it looks like it touches, but it really doesn't. It's just that it's the pen's too thick, or the pixels on your calculator will be too thick. And this is at y equals, and it hits the y-axis at 1. And this one here was x equals -2. So it has a horizontal asymptote at y equals -1. Again, if you just put -1, it's wrong. Now in ALEKS, it might have the y equals part to begin with, so that's different. But the equation of that horizontal asymptote is y equals -1. Now, domain. Domain always came from the denominator. You know, it's what x can't be, or at what x can be. So here's what you do. X can be any of these numbers except where this horizontal asymptote is. Notice there is nothing at -2. There's one at -3, -4. There is a part of that graph at those numbers. Same thing over here. It's just not at 2. So how do we take out the 2? You go from -infinity up to 2. And what do we use? Bracket or parenthesis? What takes it out? I just didn't hear. No. Parentheses. That's okay. I'm seeing that a lot. And it's not just one person. Okay. Remember, parenthesis is not included. I don't think you were the only one that said bracket. Parenthesis, and I'd rather you try than not try. Okay. Parenthesis is not included. That took care of all these here. Okay. That took care of all of these values from the left coming to that asymptote. And then it says, okay, at -2, it's not a +2, at a -2, we can't have it. Well, we need everything to the right of it. We're going to take that parenthesis, -2, and go to the positive, to the right of that. And then we just put a union, okay? So remember, to take things out, it has to have a parenthesis. See, and it's not on here, but if you had done this, -infinity to -2 in a bracket, and then a bracket and -2 to infinity, that is the exact same thing as -infinity to infinity. It's the exact same thing. Brackets mean it's allowed. Parentheses, no. Okay. All right. It's okay. Now, for the range, it can be everything except where this horizontal asymptote is. So to take out 1, you're going to do the exact same thing. You're going to say, move this up a little bit, -infinity up to 1. What are we going to use? Parentheses or bracket? Parentheses. It will be parentheses. If you're taking something out, it'll always be parentheses. 1, 2, infinity. Okay, that's how you take out. Remember, if you're taking things out, domain and range are parentheses. Okay, very, very, very common mistake to use brackets, but I think now people won't use them. Okay, because of this. All right. I want you over here. We now are going to have 2 vertical asymptotes here, and you have one here. So what I want you to try on your paper is I want you to find the x-intercept, I want you to find the y-intercept, and then the vertical asymptotes. You have 2 of them. Okay, it crossed the x-axis at 0, right? Again, I'm not sure if it wants 0, 0, or if it just wants 0. Okay. And it also crosses the y-axis at 0, 0. Our vertical asymptote is, so it looks like negative, that's -3, right? And this one is +3. I want to tell you this though. If you have two vertical asymptotes, I need to see two equations of lines. It needs to be separate. It doesn't need to be x equals -3, 3. I want two separate lines. All right. These aren't solutions. These are actually equations of lines. And if you have two lines, you need two equations. Okay. Now, the reason I waited on the horizontal one is because some of you may say there isn't one because it crosses here in the middle. On the horizontal one, it only affects the far left and the far right. So if you look at this left part of the graph and the right part of the graph, it actually is not going to cross either place. It's okay in the middle. It horizontal only affects the far left and the far right. So there's one right there. And that is at x equals 0, or y equals 0. Now, again, it's okay to have it cross in the middle because it only affects the far left and the far right. Now, see, this one doesn't even touch it, but this one kind of does. All right. Now, domain. Domain, you are going to take that from your vertical asymptotes, just like we did over here, okay? Over here, we took it from this vertical asymptote, but now we've got two of them. We have everything to the left of this -3. Well, you're going to write that as -infinity to -3, and you're going to use what? Parenthesis or bracket? Parenthesis. It's going to be the same every single time, okay? But this is where people will forget. That took care of this here, right? Well, we also have things between here and here. We also have that. So between -3 and 3, parenthesis, -3 to 3. And then you have the far right of this asymptote, or the right of this asymptote. So it's from 3 to infinity. Notice we use parentheses. Okay, the range comes from the horizontal asymptote. It can be any number but 0. So again, parenthesis, -infinity to 0, parenthesis, union, and then parenthesis, 0 to infinity. Okay. Now, we are going to go to the next page. All right. Now, on the front page, it will tell you this, but vertical asymptotes come from your denominator. Okay, vertical asymptotes come from your denominator. So what you do, I'm just going to put denominator over here. Okay. What you do is you take your denominator and you set it equal to 0. So what would x be? -5, good. So we have x equals -5. See, before, you remember our restrictions? We said x can't be equal to -5. The reason it couldn't be equal to -5 is if it was, we have a vertical asymptote. And that's what happens on the graph, because now we're talking about graphs of these, where before we were just talking about domain and range. All right, I'm going to go through all this whole page and let's do vertical asymptotes first. Okay, so again, on the vertical asymptotes, you take your denominator and you set it equal to 0. So right here, I'm going to take that 5 to the other side and it becomes negative. Divide by -2 and we get a x equals 5 halves or 2.5. I don't care which one you use. 2.5 or 5 halves, both of them are the exact same thing. Right here, and by the way, see how this is x? You will only have one asymptote. If it's an x squared, you're going to have 2 asymptotes, or could have 2 asymptotes, vertical asymptotes. Depends on what this is. You still take x squared minus 4 equals 0. And now you solve that. You can solve this 2 different ways. You can factor it, or you can use square root method. I don't care. It's just that those of you that would take the 4 to the other side, then take the square root, make sure you take the positive and negative square root, which would be 2. Or, this is easy to factor, x plus 2, x minus 2 equals 0. So you have 1 at x equals a -2 right there, and you have x equals 2 right here. By the way, I want you to know they don't have to be -3 and 3 or -2 and 2. Sometimes you might have one at 1 and one at 4. It just depends on what the problem reads. Right here, you still would take this and set it equal to 0. But guys, this will not factor. You're going to try to factor it, and I'm going to get -1 for my answer or +1, and it's going to be wrong. Okay? Because think about it. First of all, this won't factor. It only factors if it's a minus sign. Nothing with a plus. There's no number that I can square and add 1 to it to give me 0. Some of you are going to say, well, what about -1? -1 squared gives me 1. Plus 1 is 2. So if you say it's 1, 1 squared is 1, 1 plus 1 is 2. There's nothing out there. The only way that you could possibly try to solve this would be to take that 1 to the other side, but then you get x squared equals a -1, and then you take the square root. But are we allowed to take square root of -1 in this class? No. We've never learned that. You're not allowed to in this class. It's an imaginary number, but we do not teach that in this class. So here, there are no vertical asymptotes in that case. Find your vertical asymptote here. You've got -1/2. Find here, you're going to have 2 of them. So you're going to factor it. It factors as x plus 6 and x plus 1. So you're going to have x equals 6 here. That's one of them. Here you're going to x equals a -1. That's the other one. Okay. All right. These two, I want you to find your vertical asymptotes. What is it going to be here? 2, good. X equals 2, because again, you have negative x plus 2 equals 0. You can subtract 2 and divide by -1, or you can just take this x to the other side and get 2 equals x. Okay, so here, what do? When you are going to be asked, you are going to be asked to graph these, okay? So all you have to do is go over here at 2 and put a vertical asymptote at 2. Make sure it's dashed. I will call it dotted just because it's easier for me. I don't know why. Just I don't know if I was taught that, but that's all I've ever said is dotted. Okay. So now, where's my vertical asymptote here? -1. Nice. Okay. So now you just go over here and put a dashed line, the vertical asymptote, and it does need to be dashed. It doesn't need to be solid. Solid lines means it's actually visible. But if you're to graph these, you aren't going to see them. Okay, so, all right. Let me just put that so it doesn't go off again. All right, so that's vertical asymptotes. All right. And they don't, not everything has a vertical asymptote. Just want you to know that. Not everything has it, okay? By the way, I already have graphed this from my last class. I want to show you something. I went into y equals and I put that in. When I graph it, it looks like this, but you will notice vertical asymptote at 2, okay? Vertical asymptote. See how that line does not cross? Or those, the graph doesn't cross this point. It looks like it approaches it, but that's because of pickles. The pixels are too large, okay? So, okay. Horizontal asymptotes. Horizontal asymptotes, to me, okay, when I was getting ready to teach 1710, we teach this stuff. And I looked at this and I went, oh God, that's so many words. I needed shortcuts to it. And then I was flipping back and forth between the, because guys, I know when you expect the teachers to be able to just come in and teach. I can now. But when I started teaching these classes, I never remembered doing them. I'm sure I did because I'd heard of asymptotes. But I hadn't done them in like 20 or 30 years. So I had to go take my notes and do them once. And I kept flipping the pages back and forth with these rules. Then I'd go through it again after I did that, do it again, see if I needed to add little things for me to tell you guys. And then I'd do it a third time. That's how I know how to do it. Notice each one of these, I did the exact same way. Do you know why? So that when you get home, you'll do it this way. And if you won't, hopefully doing this in class will help you. I told one of my classes this morning, I know you're doing your math problems on computers, but you take your test on paper. And some, like next semester, they may not use a computer program. You've got to learn how to do things on paper. So this is why, if it were me and you were wanting to learn it for the next, to retain it, let's say, then do it on paper and enter your answers in. You need some notes to just help you remember it, right? Like here, this is not hard vertical asymptotes, but you have to remember that it comes from the denominator, setting the denominator equal to 0 and solve. Okay, so a lot of words. So I took a Post-it note and this is what I wrote down. Okay, let me erase some stuff here. I don't have to write everything down again. And I don't have any pink paper other than this because it disappeared in this class. Okay, I should have erased this before. I wasn't thinking about that, really. Okay, so here's what I had to do. Or here's what I did. Okay, to find horizontal asymptotes. So I take this little Post-it note here, okay? and I write this down. So write down compare numerator degree to denominator degree. I didn't write out numerator because it's too long for me. Or you could put compare the degrees. I don't know. Whatever, these are your notes, it's for you to use so you don't have to keep flipping back and forth. Okay, there's going to be 3 scenarios with this. The first one, the numerator degree is going to be less than the denominator degree. Okay? That's going to be the first one. If that's the case, you have a horizontal asymptote at y equals 0. The second case is they could be equal. They could be equal. Numerator degree equals denominator degree. And I'm going to write this every single time today. And I don't need to, but I do that so that you guys will get in the habit. It just might help you come test time or when you're doing your homework and you're not struggling. Right? Because I promise I will get a question. How do you find the horizontal asymptotes? And I'll be like, go to your notes. No, I won't. I'll say compare the degrees, and then hopefully you'll go, oh yeah. Okay. Numerator degree is equal to the denominator degree. Well, if that's the case, you are going to your horizontal asymptote, and these are horizontal asymptotes, I should say. You are going to put your leading coefficient of your numerator over your leading coefficient of your denominator. Now, if LC does not work for you, then write out leading coefficient, okay? That's what it did on the page before. If you look on the front page, you'll see leading coefficient of numerator in the numerator, leading coefficient in the denominator, okay? I just didn't need that because I know what LC means to me. Okay, so you're going to have some constant there. It's going to be like y equals 2, y equals negative 1/3, something like that. And then the third scenario would be the numerator degree is greater than the denominator degree. Now, in your class, you're lucky because all you're going to write is no horizontal asymptote. And I don't know why I just didn't put HA, but and you're done. In my other class, they would have to try to see if there's a slant asymptote. Because sometimes you don't just have horizontal and vertical, you sometimes have a slant like that. Okay, but you guys don't have to worry about that. That makes your life easier. Okay, so now I'm going to bring this back and we're going to use it. So here's what we're going to do. We're going to go up here and we're going to find the degrees. Okay, right here, degree equals 0. Right here, my degree is 1. Now, I will say this. Some of you are going to mess up right here because you don't know the degree. It would be 3x to the 0 power, but anything with 0 power is 1, so we don't write it. All right. So here's what we're going to do. The numerator degree is less than denominator degree. I know it's a lot of writing, but I'm telling you, the more you do this, it will become very easy for you. Okay, well, so I go to my handy dandy post-it note and I say, oh, the numerator degree is less than the denominator. I have a horizontal asymptote at y equals 0. And I'll move on. Because we're not really having to graph or anything like this. So right here, my degree here. What is my degree here? Anybody know? Do you know how to find the degree? We talked about it. It's the highest exponent on x. So this one would be 1. And same thing here. Now, it's kind of important because that is where the leading coefficient comes from as well. Okay, so the numerator degree equals denominator degree. Well, when that's the case, we're going to put our leading coefficient over leading coefficient. All right, well, our leading coefficient of our numerator comes from our highest degree on x, okay? Well, it has a number there, we just don't write it. This is a positive 1. Our leading coefficient here is a negative 2. So we have negative 1/2. It doesn't matter where the negative goes. Usually goes in the middle, but wherever. It's 1 over negative 2, which gives us a negative 1/2 or negative 0.5. I don't care. Right here, let's compare our numerator degree with our denominator degree. Now again, none of this is hard, but when you go to work on it at home, you may not work on it right away and you'll forget. And then you take these out, okay? So our numerator degree here is 2. And here it's 2. So these are equal. So you take this out and you go, oh, they're equal. Leading coefficient in numerator over leading coefficient in denominator. So the leading coefficient here is a 2 because that's what's in front of my x squares. My leading coefficient here is 1, right? So it's 2 over 1, which is what? Just 2. So y equals 2. I did it this way so you know how we got 2. Okay. All right. Right here. Degree is 1. Degree is 2. So our numerator degree is a less than denominator degree. Handy dandy post-it note. Where's our horizontal asymptote? Less than, so it is 0. Now here we have a degree of 2. Here we have a degree of 1. So in this case, our numerator degree is greater than our denominator degree. Yeah. When that's the case, there's no horizontal asymptote. No horizontal asymptote. And you can just put HA. Find your horizontal asymptote here. What's it going to be? Anybody know? First of all, is the numerator degree greater, less than, greater than? Let's try to skip it. Is the numerator degree less than, equal to, or greater than the denominator degree? They're equal, okay? Because this has a degree of 2 and this has a degree of 2. Well, when they're equal, leading coefficient of numerator over leading coefficient of denominator, so we have 1 over 1, which means it's y equals 1. And I forgot to say on this that the numerator degree equals denominator degree. Okay. I want you to find the horizontal asymptote right here. Anybody? It's 0, right? Because this has a degree of 0. This has a degree of 1. When it's less than, when the numerator degree is less than the denominator degree, it's y equals 0. So that means the x-axis right here, there's a horizontal asymptote. At y equals 0. That's the x-axis. Okay. Let's find the horizontal asymptote here. Degree of 1. Degree of 1. So you put they're equal, leading coefficient in numerator over leading coefficient in denominator. So that'd be 2 over 1, which is y equals 2. So right here, you have this horizontal asymptote right here. Now, at this point, that's all it says. Oh, it does say graph the function. Okay, I did do this last class, but I was just doing it, not paying attention to directions. Okay, I thought it just said graph the asymptotes. All right, so basically what you need to know is you're going to have two curves on this one right here. Are they going to go here and here, here and here, here and here, or here and here, or here and here? Okay, we got to figure that out. Now, yes, you can graph it on your calculator, but I don't really need to, because here's how I would do it. I'd first say, okay, where is it going to cross my where's my y-intercept? I would say x-intercept, but because we have an asymptote there, it's not going to cross there. So if I wanted to find my y-intercept, I plug in 0 for x, right? So I'm going to have -1 over 0 plus 2 gives me 2. -1/2. So I would graph that point. Well, guys, it cannot cross those asymptotes. So if it goes this direction, it's going to approach it, but never cross it. And if it goes this direction, it's going to approach it, but never cross it. Okay, so that's one, right? That was easy. All I had to do is find the y-intercept. I would have had that graph before you even got your calculator out and started plugging it in. Even on this one, I need to find one other point, okay, to see if it goes here. It's not going to go here because I've used all my x values on the negative side. I need to use some of these x values on my positives of this asymptote. I've used my x values to the left of that asymptote. Give me one of these numbers. I don't care which one. Just give it to me. 5. Okay. So what I'm going to do, if I make x equal to 5, I'm going to plug it in. I don't know why I wrote it like that. If I made my x 5, I just need to find out what my y is. I'm going to have -1 on the top. When I plug in -5 here, it gives me -5 plus 2 gives me -3. Well, what's a -1 over -3? Positive, right? So that gives me a positive 1/3. Just by plugging it in, that was it. Well, graph that point. 5 up 1/3, about right there. It's in that quadrant. So that curve's going to go like this. It's going to go this direction. approach that asymptote, and it's going to go this direction, approach that asymptote, but never cross. Be careful. Because honestly, what I'm going to see on people who don't really understand the asymptotes and you only know how to use your calculator, you'll take your calculator out and you'll plug this formula in, this function in. And I'm in Zoom 6, okay? And it's going to graph. Notice what it does, okay? Now, doesn't that kind of look like what this is? Asymptotes aren't on here, okay? But this is what I'm going to see on a test. I'm going to say graph it neatly. And some people are going to do this. This is the graph that I'm going to get. It's not really that bad. They're going to do this. That's what I'm going to see. All right, first of all, there's no asymptotes in there. Okay. Second of all, there was an asymptote at 2. Let's say this was 2. This is what I'm going to see. And all that tells me is, oh yeah, you know how to plug it into your calculator. Now, I will say this. You cannot put vertical asymptotes in your calculator because it's an x equals, right? But a horizontal one you can because it's a y equals. And watch, it's going to look like they cross though. That's the only bad thing because of pixels, all right? You have this red line that went across there, okay? It looks like it touches and crosses, but it really doesn't. Okay, let's go to this next one. Again, you can use your calculator on here, but you do not have to, because I'm going to find my y-intercept by plugging 0 in for x. I'm going to get -4 over 1, which is -4. 0, -4 is right here. I know it's going to go like this. Because that's how it has to go in that quadrant. Only knowing this point right there. Just knowing that. Because again, it's going to go down. Okay. It can't cross this here. And it can't cross this here. So that's how it's going to go. Now, these don't have to be perfect. Now, I am going to make this a better line, though, a better curve. Because I just figured out it may not be a great curve unless I got lucky. Okay, because here's why. It's going to cross the x-axis. So what I could do is I could find, this is my y-intercept. To find my x-intercept, I just plug in 0 for y. So I would get 0 equals 2x minus 4 over x plus 1. We learned how to do this. You multiply both sides by x plus 1. And across multiply, it doesn't really matter, because watch what happens. These cancel. And we get 0 over here. So 0 is equal to 2x minus 4. Add 4. And then divide by 2. So I get x equals 2. So my x-intercept is 0, 2. See how bad this curve is? I really now should put it here. And make sure it goes through both of those and curves. So that's really bad. I tried to make it work and I knew it wasn't going to. That's better. Not great. Now, I know where my other curve is. It can't be over here because there's not another x-intercept. We only had one, right? So that's the only place. So it can't be over here because it would cross the x-axis. I also know that it can't be here because we've used all the numbers down here. So I know it has to go here. Now, you could graph it And I'm gonna go ahead and put in my asymptote also. But if I graph this, this was 2x minus 4 on the top and x plus 1 on the bottom. And that we have a vertical asymptote at, a horizontal at y equals 2. Okay. And that's what we have on here. The only thing it doesn't show is our vertical asymptote, but you can find that. You know how you could find that? It's at x equals -1. If you go to your table, look where the error is at -1. So that's where I know that's where that asymptote is. So that's how, again, you can use your calculator or not. Okay. Graph the vertical asymptotes. Okay. Right here. We're just doing the asymptotes, but I want you to go ahead and try that. Where does the vertical asymptote come from? Are you comparing degrees, or does it come from the denominator? This is where you turn your paper over and you look to see where it is. And you'd say x plus 2 equals 0. So there's 1 at x equals -2. So you put in your vertical asymptote at -2. And now you do a horizontal asymptote. Compare your numerators, degrees, I should say. Numerator degree is 0. Your denominator degree is 1. So it is less than. So our horizontal is y equals 0. Again, degree here is 0. Degree here is 1. So we have this right here. Again, make it a dashed line on the x-axis. Now, it didn't ask you to do the graph. It just says graph the vertical and horizontal asymptotes. But it would be so easy to figure out where the graphs are without using your calculator. Somebody give me a number besides this -2, because x can't be -2. Give me a number. -4. Okay, so that's going to be somewhere over here. It's either going to be here or here. All you do is you plug -4 into here. You get 1 on the top. -4 plus 2 gives me -2. So -4, -1/2 is right here. Oops. Why did I? Oh, never mind. It's right here. So I know it has to go like this. It can't cross either of those lines. So that's how it has to go. Just from knowing that. I didn't plug it in my calculator. It's easy. 0. I like 0. It's to the right of this. The reason I like 0 is I plug it in and I get 1/2. 0 up 1/2. God, it's really hard once you put that asymptote. 0 up 1/2 is right here. And so now I know it goes like this. If you didn't even like that, you could have used -1 even. -1. If I plug in -1, I get 1 over 1, which is just 1. Now, again, that would have been that point. So again, it still would have been like this. Same thing. Okay. Okay, we will pick up with the last 3 of these on Wednesday.